Greetings and welcome back. In this video we're going to be talking about the idea of modules and functions in Python. And functions are a really powerful tool. They allow us essentially to create reusable pieces of code that we can use in one application and then even share between applications. In this video we're going to be talking about how we use functions, how we take big problems, how we break them down into subtasks and turn those subtasks into functions that we can reuse. And then we're going to actually talk about the syntax of functions. We're going to show you how you define your own function in Python and then how you can call it or use that function over and over and over. And this is going to make our program smaller, it's going to make it more manageable, and it's going to make it so that it's easy to fix mistakes if and when they happen. So why don't we go ahead and just get started? Rather than go to the slides immediately, why don't we practice our IPO skills and let's write a program real quickly that converts 7.3 terabytes to bits. So this should be relatively easy to do. I'll make a variable here called numbytes, and I will set it equal to 7.3 times, over here I put the conversion factor, so 1 terabyte is 2 to the 30 bytes, so it should just be number of bytes times 2 to the 30, 2 to the 30. And then if I want to get bytes to bits, I just take the number of bytes and I times it by 8. And then now I'll just print out the number of bits. Okay, so this program, if I press play, it works, or at least it looks like it does. 7.3 terabytes is definitely a lot of bits. So, okay. Why don't I go ahead and say, now I have this code, now let's do it for 5.1 terabytes. Okay, and you just copy and paste the code, replace this with 5.1, and this should print out 2 sets of bits. Okay, that's good. What about 5.9? That's fine. I can go ahead here and 5.9, and okay, that'll work too. Well, what happens if I keep doing this over and over, right? At 2.1, 8.3, 8.3. The program works, but you're seeing there's a lot of redundant code. And this is fine if you don't mind a little bit of redundancy, but let's say that I have to convert hundreds and hundreds of numbers from terabytes to bits. This could get a little unwieldy. More importantly, did you notice I made a mistake? 1 terabyte isn't 2 to the 30 bytes, it's actually 2 to the 40. So if I encounter a mistake, I actually need to go and find every single instance of my code of where the error is and change it. So you can control F, but that's not always going to work on big programs. You might make some extra mistakes. So you can see how this strategy of copying and pasting code is going to get a little unwieldy. And that's why today we're going to show you how you can eliminate this by having functions. A function is essentially a reusable chunk of code. The idea is that I define a function in one place, and then anytime I need to do that thing, I can just call the function and have it do it. You can think of it as kind of like a recipe. It's a set of instructions that will produce something for me, and whenever I need it, I just use that recipe. Alright? So functions are really small, they tend to perform just one task, and we'll talk more about that in a minute, and they are self-contained code. So all the code for that function, it's designed to be a little module that I can run around with, and I can move in and use in different applications if I need to. So rather than just talk about this abstractly, let's do it. Let's just turn this into a function. So rather than have all this code, why don't I go ahead and define a function? So to define a function in Python, you just type def, that means define, and then you give it the function a name. You can name it whatever you want. This is America. Here I tend to make my functions very explicit so you know what they're doing. So terabytes to bits is the name of my function. And then I'm going to have open parentheses and close parentheses. And here, this is where I specify what information my function needs from the outside world to work. So in order for this function to convert terabytes to bits, I need to know how many terabytes you want to convert. So I'm just going to name it. It's like naming a variable, terabytes. And then I'm going to put a colon. And when I press enter, this is the same as if statements where it indents. Everything in the indent is part of my function. So okay, now I'm actually going to go through the same math. I'm going to say the number of bytes is equal to, and I can treat this is called a parameter. I can treat this basically like a variable. So at the time I'm writing the function, I don't know what's in here, but that doesn't matter. I can just say it's whatever I was provided times 2 to the 40. And then I can say it's num bits is equal to num bytes times 8. And then I can print num bits. So if I was to run this program right now, you would see that it doesn't do anything, and the reason for that is that a function does not run on its own. Functions don't run. They are just pieces of code that are on standby whenever you need them. So whenever I need to convert terabytes to bits, what I do is I call the function, and calling just means tell my program to use this function. So the way I do it is really simple. I just type the name of the function, terabytes to bits. Then I open parentheses, and inside here I give it whatever information the function needs. So we said here that this function needs the number of terabytes to do its thing. Okay, well then I just type 7.3 here. And when I press play, now it actually runs that code, right? And I get an answer. So this is great because now whenever I run this, if we actually use the debugger, what you'll see is that this is the first line of the code that actually executes, right? Functions do not run on their own. They have to be called. And then, if I actually step into, you'll see what it does is it actually goes into that function and starts executing that code. So you can actually see it running in and doing all of the work. And then we're done. So this is interesting. So now anytime I want to use this function, I can actually go ahead and, right? So now if I want to do 5.3, 1.2, 7.6, 11, 0.4, whatever. It doesn't matter. That function works. But more importantly, if I need to make a change, let's say I don't want it just to print out a number, I want it to print out the units. So now it will say, this number bits. So all I have to do is change it in one place, and every time it calls it, it automatically makes that change. So you can see that I've made a piece of code. And remember, this is self-contained, so I could move this to other applications as well. So it's really kind of cool. Now I have code that I can write, it's self-contained, I can call it whenever I need it, and if I ever need to make a change, I just make the change here, and everywhere it calls it, it will fix it on its own. So as a general rule, when do you need to make a function? It's typically when you need to do something more than once. Again, making reusable code allows us to make shorter programs and make programs that are easier for us to manage. And again, we're going to go through the pieces just so we remind ourselves. Def means define. That's the keyword to let Python know we're defining a function. We name the function. And then here is the list of parameters. So you can have 0 or as 100 parameters. It doesn't matter. But a parameter is basically what information does this function need to do its job. This is the code that is actually inside your function. So these are called local variables. And the reason for that is these variables only exist inside this function. Your main program cannot see them. And then remember that we're indenting the code. So that's functions in a nutshell. So in this video, I basically showed you how to take code that is redundant, turn it into functions, and then call that function in your application. And in the following videos, we're going to talk about the general concept of why we do this and how functions are a valuable tool for us to manage program complexity.